Hello and welcome back. Now, we've created a beam burst Niagara system, and it looks pretty good, but we'd like to spawn these in the game when our enemy is blasting, when our bot is blasting those beams. And we want to blast those at the barrel tip. So we're going to get to that. But before we do that, we're really quickly going to fix this really annoying problem. As you can see, the light keeps adjusting and it's really blinding. Everything is really, really bright. And that's kind of distracting, and it also doesn't really look all that great. So I'd like to fix that first before we move on, just so we don't have to deal with that. Now, to fix that, we're going to want to add a specific type of volume to our level. And that type of volume is a post-process volume. Post-process volumes allow us to define the overall look and feel of our levels based on a number of settings, and that auto exposure, where it looks like our eyes are adjusting to the light, that's a setting that we can change in a post-process volume. It's something that a lot of players and developers alike don't really like. I personally don't like it, and we're going to fix that by adding our own post-process volume. Now, this icon, as we've seen, allows us to quickly add certain types of items to our world, and post-process volume is under volumes. We can go down to post-process volume, and we have these little handles to the right. We can actually click anywhere on the bar that says post-process volume, but we can click and drag one of these into our level, and we suddenly have one of these volumes now. Now, by default, post-process volumes only affect what we can see when we are inside of that volume, when the camera is inside of it. But we can have our post-process volume have an infinite extent, meaning that it affects the entire level. So to do that, with our post-process volume selected, as we can see in the outliner, we go to the Details panel and we search here for Infinite. And there's an infinite extent, in parentheses, unbound option. We can check that. And now our post-process volume is going to affect the entire level. And now we can set some properties on our post-process volume to change how things look. And what I'd like to change is under the exposure category. If we search for exposure and we scroll down slightly, we have a minimum EV100 and a maximum EV100. And the tooltip tells us what these do. Auto exposure minimum adaptation, it says. Eye adaptation is disabled if minimum equals maximum. And then it gives you a very technical explanation as to what it does, but all we have to understand is we can override these values by checking the checkboxes and set them both to the same value, such as 0. And all of a sudden, that white glowiness to our level is gone. And if we go outside of the shade here into the sun, we'll see it's nice and bright, and down into the shade, it's nice and dark, and we don't get that auto exposure, that eye adjusting to the light effect. That was what I wanted to disable. And of course, there are a ton of other settings in post-process volumes that we won't be getting into just now, but we've now fixed that problem of auto exposure, and things are going to look a lot better. Now, because our post-process volume is infinite extent, it doesn't matter where it is, so I'm going to move it up. I'm going to grab the translation gizmo and hold Shift to move it up and bring the camera with it, and just bring it way up out of the way so that it's not going to be a distraction for us as we're playing. And I can do the same thing with these other objects as well. We have our volumetric cloud. I'm going to hold Shift and select the next one. That's the skylight, the sky atmosphere, and the directional light. I'm going to bring these all up out of the way, and now we have some room to work. Okay, so now for the task at hand. I'd like to show that particle system right there at the tip of the barrel whenever our drone fires its blaster beam. And we can take a look at BP bot to see when that happens. If we look at event begin play, We first store our target pawn, and we can double click on this function to go inside of it and remind ourselves what's happening there. We're getting all actors of class. This returns an array. We're checking the first index to make sure it's a valid index, and then getting the actor at that index and storing it in our target pawn. It's a pawn because get all actors of class is filtering based on the pawn class, so we know we're only getting a single element in this array. I'm going to go ahead and close that tab down and go back to the event graph to see that after we do that, we're waiting for 2 seconds with a delay node and then spawning our blaster beam or spawning an actor at the transform of our socket rifle L on the bot mesh. And then we're spawning another one at the socket rifle R. Now, these both happen at the same time, of course, and later we're going to want to stagger them and shoot from the left rifle, then the right, then the left, and so on. And we'll get to that soon enough. But for now, whenever we spawn our blaster beam at the rifle location, at that socket, I'd like to also spawn a particle system, specifically our beam burst Niagara system. So how do we do that? It's actually quite simple. We can right-click and search for spawn system. And we have a number of choices: spawn system at location with params, spawn system attached, and attached with params. Now, we don't need this system to be attached. We just want to spawn it somewhere. So I'm going to use spawn system at location, hook that up, and take a look at its input parameters. First, we have system template, and this is where we select which Niagara system to spawn. If we open that dropdown, we see that our project only has one, our beam burst that we created. So we can select that. And next we need a location, a rotation, and a scale. Now we want to spawn this at the location of the rifle, specifically at the socket at the tip of the rifle. And that socket has its own transform. It has a location, it has a rotation. And it's important that we use that rotation because the socket's forward direction is pointed in the forward direction of our drone. So we're going to go back to the event graph. And I'd like you to just really quickly take this as a mini challenge. I want you to get the correct inputs for location and rotation. And notice that scale is by default the vector 1, 1, 1. This means we're not going to scale that system. It's going to come in at its normal size. So really quickly pause the video and fill this in, location and rotation. Okay, so what we need to do is we need the location of our socket. And if we right-click and search for Get Socket Transform, we're going to see that we have Get Socket Transform from the bot mesh. That's the one we want because the bot mesh is what has the socket, right? Now I'm going to right-click on return value and split the struct pin, and that will allow me to get the location and hook that in for the location, and the rotation. We'll hook that in for the rotation, and we don't really care about the scale. It can just be 1. Now the socket name has to be the correct socket name. We can remind ourselves by coming back over here. We have a rifle L and a rifle R, so we can paste one of those in, and now we have the correct inputs. Now, some of the other inputs are auto destroy. That means that once this system has been spawned and it's done, it will destroy itself. It cleans itself up. We don't have to worry about deleting it or anything like that. And auto activate makes sure that it automatically activates. That's pretty self-explanatory. Now, pooling is a method of optimization for particle systems. We don't have to get into it for now. We can just leave that at none. And same for pre-cull check. We can just leave that at defaults. And we're now going to spawn a system at the rifle L location. This is at the same time as the spawning of beams at both rifle locations. So let's see what that looks like. Before we play test, though, I'm going to take this particle system, which is just going to burst when we press play at the beginning of the game. I'm going to delete that, and we're going to press play and wait for 2 seconds, and there it goes. So we saw that explosion, and we only saw it at the left rifle, right? Because we're only spawning one. But we can go ahead and spawn a second one if we like. We can make this easy by highlighting all 3 nodes, Control D to duplicate and hooking them up, and simply changing this get socket transform to get rifle R. And now we can just go press play. And after 2 seconds, there we go. We get the particles on both rifles. Excellent. So now we're spawning a system, and it's spawning at the location of a specific socket, right? But we've seen previously that it's good to keep our nodes nice and tidy. If we have several nodes that do one thing, it's handy to just collapse them into a function and call that one function whenever we want to do a specific thing. One indicator that we should be collapsing certain nodes into a function is if we repeat ourselves. We're repeating ourselves here by first spawning the beam at the left rifle, and then spawning the beam at the right rifle, and of course doing other things like spawning particle systems at the left and then the right rifles, respectively. This is an indicator that we can create a function to make our nodes and our lives neater and easier. So we're going to make a function, and I'd like to make a function that's generic. I don't really want a function for spawning at the left rifle and then a separate function for spawning at the right rifle. I'd like one function that can be toggled between left and right. The only difference between spawning at the left and the right is the socket name, right? So let's make a function, and rather than being lazy and collapsing nodes into a function, this time I'm going to click Add under my blueprint and create a new function, and I'm going to call this Spawn Blaster Beam. And Spawn Blaster Beam is going to be versatile. We can use it to spawn at the left rifle, and we can use it to spawn at the right rifle. We just need to pass in an input to specify which one. So in the Details panel under Inputs, we can click plus. And how do we specify which socket to spawn at? Well, that's a name. So we can change the data type from Boolean to name, and we can call this input parameter for the function socket name. And now whenever we call spawn blaster beam, we can simply pass in a socket name. And we want to spawn an actor, right? Well, that's something we can come back to our event graph to copy some nodes for. We can take spawn actor BP blaster beam. I'm going to hold shift and select both get socket transform and the bot mesh node. Control C to copy and come back to spawn blaster beam. Control V to paste and hook these up. And now we have a function that's going to call spawn actor BP blaster beam. Except we don't want to spawn at rifle L. We want to spawn at the socket name that we pass in whenever we call this function. And we have access to it from the input node. So we're going to take the socket name and hook it up to get socket transform here. And now our function is going to spawn our blaster beam at the socket location based on that name that we pass in. So if we go back to event graph and we take these nodes, spawn actor BP blaster beam, get socket transform, etc., and we delete those, and instead we bring in spawn blaster beam and call that instead, we can now pass in a socket name. Now it has to be correct, so let's use rifle underscore L, and we can go back and play test to see if we get that rocket spawned at the left rifle, and we do. So we already have a function we can replace these nodes with for the left and right rifles. So what I'd like to do is take this spawn blaster beam, use Control D to duplicate it, and hold Control and take this pin and bring it on over here and connect our pins. And now I don't need these nodes where I'm spawning that beam. And of course, I can hook up my nodes so we still get our particle systems. But for the second one, I have to make sure that I pass in rifle R, and that way we're spawning at the correct socket location. We can press play and just make sure that those work, and we get those beams, so it does. Now, hard coding in a name can be error prone, so it might be useful for us to just have our socket names stored as variables, so we don't have to type in or hard code those values for the names. So I'm going to drag off of socket name and use promote to variable, and I'm going to call this variable rifle socket name underscore L. So we now have a variable here, and if I compile and take a look at its default value in the details panel, Unreal Engine was smart enough to initialize it with the value that was hard-coded in the node that we promoted the variable from. So it's automatically set to rifle L, so we don't have to change that. And we can do the same thing for the input going into spawn blaster beam here. We can promote it to a variable, and I'm going to call this rifle socket name underscore R. So now we have variables. And by the way, these variables, if we select BP bot self under components, those are going to be in the details panel now. We can search for rifle, and we have rifle socket name L. We need to compile to see the newest one. So if I click compile, now I see R, and those are in the details panel under the category default. So if I don't filter, I don't search for them, they're up here under default, but we can specify our own category for these. I'm going to select rifle socket name L and go to category here and change it from default to a new category. I'm going to create a new one, and this new category can be called rifle. And now under variables, we have a rifle category. It can even be collapsed and expanded. And I'm going to take my rifle socket name R, and under category, now if I select the dropdown, we have default and we have rifle. I can select rifle, and my rifle socket names are under the rifle category. Excellent. Now, if I wanted to have a more general category that could subsume target pawn and rotation interp speed, we could have our rifle socket names under rifle and target pawn and rotation interp speed under a new category called combat, for example. So target pawn can now be under combat, and rotation interp speed can also be under combat. So now we have two handy functions for spawning the blaster beam. But notice that we're spawning systems at the location of each rifle, and these are kind of part of spawning a beam. So I'd actually like our spawn blaster beam to handle spawning these systems as well. So I'm going to copy these nodes, spawning the system, getting the transform, etc. And I'm going to go back into spawn blaster beam. I have a tab up here. I can get to it there. I could also double click on the function name under functions here. And we've already seen we can double click on the function node in the event graph as well. So I'm going to zoom out and Control V and paste these nodes in and hook them up. And now we're spawning a Niagara system, but we do need to specify that socket name. Now we know that we have access to it. It's right here. We can drag off of that and plug it right in. But now our nodes are getting a little bit messy, and we don't really like messy nodes. So I'm going to show you one more handy tip, and that's that the socket name variable is accessible in the event graph if we simply right-click and type socket name. Sometimes we may have to scroll all the way down in this pop-up, but what we want is get socket name. If we get that, we have a socket name node, and this node can be used. Instead of dragging the wire all the way across other nodes, we now just have access to it. And we can replace those long stretchy wires with just socket name. Control D will duplicate it for me, and I can hook it in. So this socket name is automatically there. It's already available by searching for a get node for it. Even though it's not a variable here on our actual actor, it's just an input parameter to the function, but we can still use it as if it were a variable. So now we have spawn system at location handled by spawn blaster beam. So we can go back to the event graph and remove the nodes that are spawning the system. We no longer need those because spawn blaster beam is going to handle that for us. So we can once again go back and press play and just wait 2 seconds. And there are the blaster beams. They're being spawned just like they were before, except we only need one function call to spawn them. And they're looking quite nice. So excellent job. In this video, we learned quite a few things. We added a post-process volume, we went to the exposure settings, and we overrode min and max EV, the auto exposure adaptation values. And when we set them both to the same value, we don't get that weird eye exposure anymore. And things are looking better now. We also learned how to spawn Niagara systems with spawn system at location, passing in location and rotation data from our socket. And we created a nice, handy, reusable function, spawn blaster beam, where we took all the nodes related to spawning a beam, spawning the actor and spawning the system, and packaged them up into a nice reusable function that can take in a socket name, and that name helps us to determine which socket transform we need to spawn the actor and the system at. And to give you a little bit of programming jargon, whenever we take a bunch of nodes and package them up into one nice, easy to use node, we call that refactoring. It's a process of making our code, or in the case of Blueprints, our nodes, tidier, easier to manage, and reusable. And this is what we refer to in programming as good programming practice. And in Blueprints, we are programming, we're just doing so visually. So it's a good idea while we're doing visual programming or visual scripting to follow good programming practice so that our blueprints are maintainable and organized. Excellent job, and I'll see you in the next video.